Hello, everyone. We will wait for just 30 seconds, then we are gonna start. Thank you. I think we can start. Hello, everybody. Welcome to the February 2026 edition of our highlight series, webinar series. I am Ertugrul Kara, and I'm joined today by one and only Patrick Staubmann, team lead of threat analysis from our labs. It's great to have you here, Patrick, in this channel again.
Yeah, thanks for having me, and hello everyone as well from my side.
So, I mean, we keep momentum going from the last one. Again, focusing on the technical, technical side of the threat landscape. And today the highlight be around, as we used in the announcement, Telegram-based infrastructure. Is kind of always absolute favorites for cyber criminals, but as well as like nation state level, state sponsored groups, threat actors as well, with different motivations. And as usual, we'll walk you through the why behind our latest detections, whether it is a VTI or whether it is something else. And quick housekeeping, we are recording this, and you get the link in a few days. Please type your questions if you have any. We have some time at the end as usual. So let's dive into it. Let's look at what we got on the deck for today. Before handing over to Patrick for the demo, in the first part, I will be walking you through our latest platform updates, detection updates. And we got a lot of high signal content. Also, see at the end, Clickfix or Pastejacking is kind of a hot threat because simply it is, just we wanted to speak about it again. We see more and more, this type of attack, and Patrick has some updates around these changing tactics. And a usual start with the newest VTIs and YARA rules, config extractors. We're going to look at our updated config extractors as well as we have a new one. They're kind of doing the heavy lifting against the latest versions of infostealers, extracting valuable IOCs, intelligence out of that. And for something a bit different today, and I think the CTI folks in the room will really enjoy this, we are introducing a threat actor spotlight. So we have always fascinating research into a group called Hydra Saiga. Maybe you come across another name, Eurotrooper, and they've been very active across Central Asia, specifically targeting critical infrastructure like water and energy sectors, distribution. We're going to quickly show you how post-exploitation looks like, and interestingly, how they turn Telegram into a core part of their campaign infra. As you see, we keep exploring how we can add more insights into this channel, this webinar series, and possibly there will be more iterations you will see in the future. So getting started, we have a lot of content today with Mr. Bean, and I think some context is to be shared here. So the first VTI of the day, and 4 out of 5 severity score, maliciousness score, because it's a very high confidence signal, we think. And now we have a detection for capturing clipboard data. That's kind of low signal. The current one, it's kind of suspicious level, and because obviously there are legit software can do that. And the new VTI we added, it's really persistent and relentless monitoring. So our labs seen this in a stealer, specifically shark stealer, and these aren't just looking for kind of random password. They seem to be specifically hunting for cryptocurrency private keys. There are some long keys that you gotta copy and paste, and some seed phrases possibly. So they could be, it could be the reason why they are this much, monitoring this frequently, the clipboard data. And moving on from Mr. Bean, next one. Some of you might remember recently we touched on a technique called ether hiding. How I'm butchering it, I know. It was again a shark stealer sample, and we touched on this in the December last year, the last edition. We felt it was critical to create a specific VTI that kind of flags when a sample starts talking to the blockchain. And it's kind of a tail to that. I really don't know if you encountered ever, hope not, but ClearFake campaigns taking advantage of this. What we see is the ClearFake loader in JavaScript initializing a Web3 connection to the Binance Smart Chain. So there's a link that's going to Binance. So the attackers can do various things with this, like they can switch second stage addresses, they can rotate infrastructure. So it's really kind of an effort around anti-takedown. And we are flagging this from now on. So the score is not that high. There can be a legit use, of course, and it's continuously monitoring, in monitor by our labs team. But it's a moderate signal of maliciousness. That's what we believe. And here is I'm sharing a great resource, a piece from Brightwell, and they really do a great job in creating such blog posts. So feel free to check out. Next one. This is not one of those techniques you see in everyday malware, everyday campaigns. And looking at the public historical reports and MITRE page, the APT groups like Lazarus, North Korean Lazarus, made use of it in the past. And actually, I will ask for some more context from Patrick here, but in a second. So just a bit more context on my end. We came across this via a public sample, and it's an Excel document. And actually, the detections on VirusTotal is not that high. You can see here, and we think it can be better. We thought it would be a good addition to the VTI portfolio we have. Also here, we some clues around this campaign as well from VirusTotal. The telemetry data shows it's kind of widespread globally, from Asia to Americas. And yeah, now I would like to really turn my head to Patrick to ask why this is something to keep an eye on. Any more context on this?
Well, definitely. I think that's just another interesting technique we do observe when it comes to especially Office documents. I mean, we all know that since the big change by Microsoft where they, block the default execution of macros when they're coming from untrusted sources has been introduced, that, all of that delivery chain,
Oh yeah, that
the
was a
years
big
we had in the
disruption for them, right?
yeah, exactly. That was basically a complete rethink, or the start of a complete rethinking from threat actors and how to infect systems. So they still sort of didn't fully get rid of Office documents. They're still being abused, and I guess we all are very familiar with, for example, the exploitation of the evasion editor. XSL script processing is just another technique that they currently seem to use to still abuse Office documents, because it's still one of the most used and probably legitimate looking ways on how to infiltrate systems. So here, actually, what's happening is that whenever you have an Office document, they're usually defined via XML files. And in those XML files, you can basically also define specific, parameters and scripts on how those documents should look like and how those are being rendered. And during opening a document, during processing all of those XML files that describe this obvious document, threat actors found a way to abuse this XLS processing to basically execute script that they can define inside of such an XML file. So the interesting thing here is that this actually happens during opening the document. There's usually not really much user interaction needed, but as soon as you open the document and all of those files are getting processed, they can actually gain code execution via this specific technique. And that's definitely something why it should be on our radar and why it's definitely important to talk about and just keep that in mind and yeah, keep it detected as well.
Yeah, that explains a lot. Thanks, Patrick, for the extra insights. So we will move forward, and I really don't want to waste time here because the full list of YARA rules is on our blog, but the variety this month is honestly impressive. So when I look at this, what I think, and it's just partial list, by the way, and what I think is just, it's a great reminder of how hard it is to fight with this threat landscape. And ironically, a fun take from this, would be a job security for all of us. All right. Yeah, anyway, now we switch gears really a bit Telegram. Probably I missed that the config extractors, but anyway, Patrick is gonna walk you through the new config extractors around Telegram Fishkit and the Vidar infostealer. So now really we switch gears. So Telegram is really one topic we wanted to speak about. And one thing to highlight here is, as we mentioned before, it's not only cybercrime, e-crime actors, but also state-sponsored advanced actors. They use it as well. And here is a very fresh CTI research from us, published just today. And around Hydra Saiga, also known as Eurotrooper, we collaborated with an external researcher, Paul Thiel. He's a talented, amazing guy, pulling these insights around, especially post-exploitation. And a quick note, it was kind of really a good example of how CTI community collaborate together. So as a VMRay researcher license holder, Paul used our sandbox for analysis of samples that these threat actors used. And whole CTI report, again, but is available today as of now on our blog. So feel free to go check out. But I'm going to share some quick summary here. So again, a quick fun for CTI folks, always hunting IOCs. And good news, we shared the IOCs on the blog, so you will see that. And it's not an image, it's just a proper table, so you can you can parse it properly for use. Also, if you want to get early access to this type of IOCs from this type of research around some specific campaigns targeting some geography, some industries, you can subscribe to our unique signal threat intelligence suite, and you can get this timely before anyone else whenever the details are ready to share. And moving forward right now, the highlights, this group is active since 2021, and it's kind of moderately, I would say, covered by the cyber security industry, we can say. And with high confidence, we can say it is state-sponsored. And in the research, it's found to be specifically targeting critical infrastructure in Central Asia. And apart from that, it's really widespread impact. It's not limited to Central Asia at all. Almost in all continents, they have either compromised or targeted organizations. Here is a snapshot to the impact. Showing some industries. You can have some clues about the targeted industries. And sorry for that. And many industries here you can see, but especially I think energy, government, manufacturing, would be fair, right? Like 3 most targeted, and those are kind of standing out when we look at the victimology. So around Telegram, so a bit step back about how and why Telegram was a choice for this campaign and others as well. So we see it's not too tricky really to exfiltrate data since it's still known as a legit application, not in all the block lists. And easy to set up, hard to take down, usual reasons really. And data exfiltration is definitely spiciest functionality that also you see on this slide is used for, but it's not really the only one. And now I'm gonna give you a quick overview from this research. For example, I mean, really, this research shined a light around that, especially to the post-exploitation activity, because what we see when you look at the blog post, the research, you will see starting from phishing, there are some documents, some encrypted RAR archives, files, then there are PDFs, and so after that, actually, the post-exploitation was kind of a dark area for this threat actor. But with this research, it's kind of really, we have more context around how they operate. And you can see some techniques facilitated by use of Telegram bot. And screen capture is one of them. You can see here some comments that's sent via Telegram. Then also a topic we covered in these webinars, disabling one Windows Defender, as a defensive agent. That's there as a comment as well to disable the some protection mechanisms on the victim device. Also to obtain credentials from operating system for lateral movement. So this was all observed as threat actors were using it. So this kind of good insight, good context. But again, the rest of the research is available, so you can check out. So that was it, really. I would like to now give the stage to Patrick. But before that, Patrick, would you have any comments around this research around Hydra Saiga? I know that you had a chance to take a look at the samples, and
well, I think
was anything really interesting? Just
it's
that you kept in mind?
definitely a very interesting research overall. I think for me, the most interesting part to know and to see is that, at least from the research, it really felt like that the threat actors had some hands-on experience. So, it's not like we usually see in commodity malware or in usual e-crime stuff where, everything is likely automated and they want to have as much as, infections as they can get. In Hydra Saiga, we actually have seen that whenever there was a successful infection, the threat actor indeed sit behind that, had some hands-on keyboard experiences and tried to, look around, navigate around. So this is really something that is interesting to see and watch a threat actor, trying to get into the system, trying to do lateral movements and things like that. So definitely a very interesting thing. And that sort of actually brings me back to Telegram, because you've mentioned it a couple of times. It's also used by Hydra Saiga, and we have a new Telegram-based config extractor for phishing kits. So that's definitely also an interesting observation we have, that if you go back in time, it often felt like to me that especially e-crime, common malware, commodity malware started using Telegram as a, command and control server infrastructure for various reasons. First of all, it's actually for free. You only have to have a phone number to register an account there. You can have as many chats, as many bots, as many bot tokens as you want to have. So it's really easy to get access to, and it's also super simple to use. Documentation is also quite well, and nobody actually has to take care of infrastructure hosting because Telegram just exists and it just runs there, so everyone can use it basically. And now we do see sort of a shift or a trend that not only let's call it for e-crime malware, maybe usually script kiddies, whatever, simpler, lower effort threat actors, however you want to call them. Not only they are actually using Telegram, but it also seems like that, as in this case for Hydra Saiga, even threat actors, maybe APTs, state-sponsored operators also start to use it basically, which is definitely an interesting shift in towards what the command and control server infrastructure looks like nowadays. And that also brings me now to the first part I'm going to show you in the demo here is that, also phishing pages nowadays seem to start using Telegram, which makes it very interesting, I think. So let me quickly take over sharing here, and I hope you can see the screen.
Not oftentimes seen, right?
Definitely.
Right now, yeah, we can see your screen, Patrick.
That's great. So we have, as already announced, we have recently introduced a new configuration extractor that tries to exfiltrate Telegram, credentials and API URLs from phishing pages. And that's also something where we see, a big uptrend currently, that not only for information stealers and for command and control server infrastructure, but also Telegram seems to be more and more used in phishing pages. So we recently came across a couple of these pages. I've just picked one of them here and added, I like the name of Peter, so just a random email address here. And we all know Microsoft, especially Office 365 login pages, are very common target of phishing attempts because it's usually used in quite a lot of different environments anyways. So what we see here is basically the analysis report of just a phishing page. We do have a proper classification. We do have a generic thread name we attach to it because we have seen this Telegram exfiltration. Just if we look through the screenshots here as well, there is this sort of page that seems to, it's not from a quality point of view up with other phishing pages we have seen as well, but there are just many out of them here. Where you see a sort of Microsoft branded background image. So it's not really the logon form that you would expect as an experienced user, but maybe you still can fall for that here, I think. So they just make it simple, and instead of getting the whole logon page, they just build their own logon page and just try to use services in the background that make screenshots of web pages and try to embed this here in the background. That's why you see the actual Microsoft web page here instead of the original login page.
Yeah, they could do better, Patrick.
They could definitely do better. There are way simpler ways to get it. Of course, we don't wanna give them motivation, so let's just keep it here as it is. But what we can actually do here is based on our analysis of the web page, based on the web behavior we see, and I've basically just interacted with the page during the analysis to point you towards what is interesting for us here. So if you look into the source of that page, you can actually see here the user side implemented JavaScript stuff. So also quite interesting because, security, sometimes I get a feeling that threat actors are usually quite far away from understanding security because whatever is controlled or whatever is implemented on the client side of a web page, that's also something that's super easy to spot and super easy to look into.
Let's not give them ideas.
No, we don't wanna do it, but maybe we can inspire actual security people to make sure that they don't implement stuff on the client side, because that's actually what happened here in those phishing pages. So what you can see here is they are actually building the message for the command and control server, which in this case is Telegram, as you can probably imagine. So they are just collecting the entered email address, the passwords. They even go further and collect information on the browser, the language, the IP address of the visitor, and even country, region, and date, and so on. So they just building their whole message together. And then they hard code the, Telegram bot token, which is basically the authentication that you need to interact with your bot, and the chat ID. And all of that information is later on being used to just forward and send all of that collected data to a Telegram channel. And that's very simple implementation. They don't need to consider much server-side stuff, except of course hosting that web page to serve it to clients. But they don't need to take care of collecting these credentials because they just have a Telegram chat bot, the Telegram chat group, where they just send all of the messages in. And This is super simple to spot. So we actually just added a configuration extractor that goes ahead and looks into web requests and the HTML pages and trying to exfiltrate exactly that information that they have implemented client side here. So we have the whole Telegram URL that's being used to exfiltrate the credentials, but we also, of course, specifically extract the API token, the bot ID, and the chat ID. Because at the end of the day, that's super helpful when you want to track them, when you want to look into campaigns, when you even want to monitoring them, because those credentials are sometimes just also reused on different places. So you actually get a little bit of a bigger picture on what's happening here. So that's the first part that I want to highlight about
Patrick,
Telegram.
just to interrupt, maybe, I mean, it's a dumb question, but we don't really see very often the config extractor for fish kits, right?
Yes.
So I just want to ask if it is extracted via static or dynamic analysis in this case.
Well, that's basically of course, a dynamic analysis, but in terms of a web analysis. So as the sample that we've submitted here, of course, is a URL, you have to have a sort of dynamic web analysis where, a client system, in this case, one of our VMs, is going to visit that page. And based on opening that page and loading the page, we basically can pass the return data from the web server, and from there we can extract this information basically. Yeah.
Right.
Okay. So as we have covered now, Telegram is being used by probably state-sponsored threat actors. It's being used in phishing. It's also heavily being used in infostealers nowadays. There are many different malware families out there, like VP keyloggers, snake keyloggers, that make use of Telegram as well. However, there are also other families. In this case, we have picked Vidar, and similar to Luma as well. They also make use of Telegram, but not for actually direct command and control server communication and not for direct data exfiltration. They use Telegram completely different in terms of their infrastructure. So, what we see here is just an analysis report of a Vidar sample. We see all of our VTIs, we see the property detection, the process change. For now, I only want to focus quickly on the extracted malware configuration here. So for Vidar, we do see a so-called first stage C2, and we see a so-called second stage C2. So the difference here is that Vidar uses existing infrastructure, in this case Steam, but also Telegram, as so-called dead drop resolvers. That actually means that the sample itself, of course, has a malware configuration that tells the malware whenever it gets executed what to do, where's the command and control server it needs to contact to basically get instructions and so on. Instead of directly hard coding the IP address or a domain that they use for the infrastructure into each binary that they distribute, they just actually hard code profile links to either Steam or Telegram profiles. So you can imagine then whenever the sample gets executed, it sees, well, there is a Steam link, basically a profile or a Telegram profile, and the sample then just contacts that specific profile. And on that profile, it will actually find the actual IP address or domain of the command and control server that it then uses, extracts, and then actually contacts here as a second stage C2, which then is the final one that Vidar wants to communicate with. There are, I think, quite a couple of different reasons on why threat actors might do that or want to do that. First of all, I think it still comes to place that Telegram and Steam looks quite legitimate, maybe in terms of an EDR or even firewalls and network appliances. So at the first execution, it doesn't really connect to any malicious domains. It just connects to existing services that are well known, basically. On the other side, it could also be quite interesting in terms of infrastructure takedowns, interruptions, or even law enforcement actions, basically. So imagine that they have maybe a couple of hundreds of thousands infected systems, and each system has a IP address that points directly to the command and control server. If this one is taken down or interrupted, then they basically sort of also might lose access to all of that infected systems. So what they do instead, they just, have those let's say, intermediate channels that they use, the profiles there, and they can, whenever they want to, update the profile basically with a new command and control server. And that's what you can see here. So I've basically, if we go to this network tab here, so during that execution, that sample actually contacted a Telegram profile, as you see here. So what I did, I've just taken that URL and submitted it for a web analysis to see what is really on that page. And if you open that page here in a VMRay analysis here, you can actually see that the description of that profile is actually this specific domain that we have also seen in Vidar basically as the second stage command and control server. So they just maintain that Telegram profile or Steam profile, can be both, can be one of them, with that specific description that actually represents the actual domain of the command and control server. For Vidar, this is usually in plain text, but for Luma, they usually have this either encoded or encrypted further, basically. And I've mentioned before that they might use it, to update the command and control server quite simply in terms of modifying that profile description. So I've made this analysis, I think roughly 1 hour before the webinar here started. And as you can see here, the domain is this GOR dot whatever, basically. But just a couple of minutes before, I ran the same analysis again with the same link basically to the Telegram profile, and it actually adjusted or got adjusted in the meanwhile. So it's still the same domain, but they adjusted the subdomain to TFX basically. That means that what I've said before, they can change these domains whenever they want to. They don't need to rely on anything else. They just need to go to that profile, change the profile description, and that's basically it. And whenever the system tries to reach out to the command and control server, it just picks up those new URL basically and can communicate with the actual command and control server. And just to give you a bit of visibility here, so we see then, of course, the communication with that specific domain here. You can see the GET request to, let the command and control server know that there is a new client probably. Then we see some POST requests. And if you're even interested in, due to the DLS decryption feature that VMRay provides, we basically also have visibility inside of HTTPS traffic. So as you can see here, Vidar uses HTTPS as a protocol. So the communication between the infected system and the command and control server is basically TLS SSL encrypted. So usually you can't read that. But due to our way on, dealing with that encrypted traffic, we do have visibility into this because we are able to extract the keys for that and decrypt the network traffic. You could even download the PKIP file, and within the PKIP file, you have already decrypted traffic. So if I just go ahead and you see here the GET request, for example, to Telegram, which is usually already encrypted anyways, you could follow that HTTP stream and you see that it's tried to connect to that profile. And if you scroll a bit down, you see actually also that the profile description here that got returned is that specific domain. If we look into other web requests here, and we see actually the communication with the Vidar command and control server. It's just going to send a hardware ID, the build ID that we also extracted basically with our malware configuration extractor. And if you go further down, there's also files being uploaded and posted to the command and control server. So yes, for example, a file name here is you can just simply take that one. It's usually just base64 encoded, and if you just base64 decode that, you see that that file is called information.txt. And if you also extract that content here, which is also just base64 encoded data, you could even get information on the version. That's the one used for the Vidar sample here. Information on the infected system. There's running processes. There is installed software. So all of that information is visible in plain text to you because we are able to read the network traffic there. And
So,
especially
Patrick, may I interrupt
with
a question from the audience? So,
sure.
by the way, again, just to remind, so Patrick is walking through if it is too fast. So we are going to share the recording afterwards, as you can check out at your own speed. So the question is, so to clarify, it gets Telegram to obtain main C2 channel, the second phase. Is it the correct framing?
Yes. So it uses Telegram profiles in the first place to get the second stage command and control server. Yeah, exactly.
Yeah.
That's how it works usually.
Yeah.
That's what we call a dead drop resolver.
Cool.
And also one of the reasons why we are able to see all of that plaintext information here, because we are able to, of course, open that, HTTPS traffic here, is also due to the fact that in that case for Vidar, they purely rely on TLS basically. So they purely rely on encrypting the network traffic on the fly. They don't apply any additional encryption layer on top of that, which also means that whenever you have the visibility into TLS encrypted traffic, you basically can also look into this one. And that's pretty handy because that gives you and researchers and analysts way more visibility in their operation, in what exactly they exfiltrate, how their exact command and control server pattern looks like. And you can even actually write signatures based on the network traffic that you see. And that's usually quite a good indicator in terms of detection and classification as well. So finally, to move towards the end here, I want to cover one of the techniques on how Vidar usually gets delivered, and Ertugrul already mentioned it before. That's about Pastejacking or Clickfix. And we have seen, I have two examples here. We do have seen sort of an interesting, well, trend, smaller changes there as well. Because I remember when we've looked into Clickfix for the very first time, I was actually part of that group of people that believed that this attack is so simple and it felt so stupid that this is never going to work out. It turns out that I was wrong, and I got proven
Yeah,
that
I remember that conversation we had in one
yeah,
of these webinars
yeah, yeah.
when
So
it
it
was
was
first popped out, and it was kind of how can, somebody uh,
yeah,
feel that much technical and really run the code, copy the code, but it turned out it's working really, really well, right? But I think you're not the only person, Patrick, who is kind of
absolutely.
still surprised.
And I guess
How,
that's also one of the reasons why we are here now, and look into those samples again, because it is usually or currently still quite high in the use of delivery chains. Clickfix is just it just works quite well. Um,
but I think they are still tuning something, and you're gonna walk us through that, right?
Yeah, things are still sort of going to change. So, for ClickFix, one of the main targets that we have seen up until now was always basically Windows systems, because, a lot of companies use Windows. It's still one of the main operating systems that dominate the market. So I have here one of those ClickFix pages. It's already a bit old. I think it's a bit more than 1 month old, and unfortunately, it doesn't really work fully anymore. So the graphics doesn't look that great. Usually there is a Cloudflare turnstile capture, which no longer is visible here. But anyways, that's not the most important point here. But if I'm zooming in here, so basically ClickFix pages always followed a same structure. So they had this sort of fake capture there, usually the Cloudflare turnstile one. And if you click that, they actually pop you up these instructions on what you have to do to fix that issue that happened. And while clicking that capture, they also, fill a usually PowerShell command, a batch command, whatever, into the user's clipboard. And then they give you the instructions as here. You have to press the Windows and R button and then type PowerShell to basically open PowerShell itself, and then press that copy button here and then paste this and press enter. And this is interesting because that's already way more interactions needed that we have seen in the past. So in the past, it usually was just confirm that capture, press Windows R, Control V, and then press enter. That was basically it. So here it already starts to also introduce more actions needed by the actual victim that is going to look into that page here. But the most interesting thing here on that page is that, at least for us, this was one of the first ones that we've looked into, where we have seen a difference between operating systems. So there is a difference if you open this on a Windows system or if you open that page from a macOS device. So for first time, we have seen that they are trying to also distinguish between operating systems and serve different commands and even different instructions here, depending on the type of operating system you use. So for Windows, they tell you to open PowerShell. For macOS, they actually tell you to open the Spotlight search and the terminal to paste in a bash command, basically. And I think that's quite an interesting change, which sort of gives us some indicators that they are also trying to go for macOS targets now, because it seems to get also more popular. Maybe there's also a bigger market for them to, infiltrate those devices as well. Because just I think today or yesterday we stumbled upon another page. It's another Clickfix page that we have here, that because we have a proper detection on that, we have YARA matches on it, we identify that there's a base checking attempt happening. Even if you look into the files tab, we also extract the clipboard content here that was put into while investigating and interacting with that page. But this page specifically seems to be designed and targeted for macOS users. So you can even see on the domain, it's called macOShelper.com. And even if you go down here and read through the instructions, that is actually opened on a Windows device. Yeah. And even if you look into that instructions, that specifically targets macOS. They give you the instruction what to do, copy the command. And basically behind that simple command is just a short bash command that simply uses curl to download and execute another file. And I think that's a very interesting change. We see that it's no longer only targeting Windows, but it's actually also targeting macOS in the meanwhile. And I think that's definitely concerning and something that, of course, detections have to be adjusted. We need to be aware of that so that we can properly defend this attack vector as well here.
Here, Patrick, I think the one question is what was the operating system in the virtual machine analyzing this URL? Why it popped up this one, MacBook?
Yeah, so basically we use for web analysis, VMRay currently only supports Windows devices. So that's also why when I'm switching back to that page here, you can only see here, of course, the Windows version of that page that got presented here. But for this page, even though you use Windows to visit that page is specifically and only designed for macOS. So this page doesn't really have any logic implemented that tells you or that tries to distinguish between operating systems. They just say, hey, if you're a Mac user, then this is relevant for you. And that's also what I guess you see here anyways.
We can say that's not dynamic, right? It is kind of...
No, this one is purely statically built. That gives you that instruction immediately. But of course, you have to click that copy button to have it. Versus the other page that I have here, this one is basically built dynamically and adjusts the content based on the browser and the operating system that you use to visit that page. So we see both versions here in the end.
And I think this also shows that, since there are some information missing right now, as you said, it's just 1 month after the attack, so that's normal. So, for example, if this analysis was done like 1 month ago as the attack is happening, analyzed in a sandbox, like through an automation or API something, so probably we would have that. We would have that visibility, right? So I think that's kind of shows again to utilize a sandbox in automated setting would
yes,
really make sense, just to even have that full complete visibility to that attack chain, how it happened.
Exactly, yeah. So as I mentioned, the other page is also quite old here. Of course, we don't see that full delivery chain anymore. An also interesting side effect around that page. So when we have looked into this one initially, the version for macOS was still alive and working as expected. It actually dropped the payload. I think it was just a stealer for macOS. But on the other side, the version for Windows, for whatever reason, never really worked because the command that they actually put into your clipboard was broken. It was actually just saying Windows_command, which is, not a valid command on Windows that you can use. We don't have any good insights or answers on the reason on why this was broken, but basically, whenever you open that page on Windows and you try to follow that instruction, you couldn't have infected yourself because it was just broken. We have also found plenty of other similar samples on VirusTotal that still followed the same logic and also were broken. So I'm not fully sure at this point if their main goal was macOS and they just built macOS initially, but constructed the page dynamically, that it in theory could also work for Windows in the future. But for now, basically, it just didn't work on Windows at all.
And I think it would be fair to say, as they see more returns from these attacks, probably they would invest more, and we will see more iterations like
It's
this, right? So this
it's
is
either like
something new.
this.
Probably there would, not probably, but certainly there will be more iterations.
Yeah,
This,
it's either like this, they are waiting for more return that they get, or the page is still in development and they are not fully done at this point. So both options, I think, are quite valid here.
yeah.
But yeah. Yeah, with that being said, that brings me to the end of our demo part, and I'll just pass it back to you, Ertu.
Thank you. Thank you, Patrick. It was a really another fantastic demo time. So I think we are good to wrap up. I can't see any more questions on the chat. So thanks, Patrick. Again, great insights, and thank you to the audience. So with us, you were with us. Feel free to connect us, find us on LinkedIn, and yeah, let's wrap it up. Um, See you next time.